alternator. So whatever the electricity you are getting, it is generated by alternator. Also it is called as the synchronous generator, or what we are calling is also AC generator. So basically the alternator or a generator which converts the mechanical energy into the electrical energy. That is, the synchronous generator or alternator is converting a mechanical energy into the electrical energy. The source of energy, the what we are getting usually conventional, or the steam, gas, then hydraulic turbine, which is driving, that is in the form of mechanical energy, that is converted into the electrical energy. That is a synchronous generator. I told you that is, these are the primary source of electrical energy we consume today. That is, you are getting the electricity, it is because of the synchronous generator which generate the electricity in the power stations. These machines are also called as a synchronous machine because they operate at synchronous speed. They are running at a constant speed. That is, speed of the machine is, it is called as the synchronous speed. That is, the speed remains the constant. Therefore, these machines also called as the synchronous machine. Once again, the parts of the synchronous generator is once again fall under the rotating machines. It has got a stator and the rotor. Then once again, to generate the electricity, we know that there are three things are necessary. Once again, you can recall, that is, a conductor is required, the magnetic field, and the relative motion between the conductor and the magnetic field. In the case of the synchronous generator or AC alternator, the armature is stationary whereas field is rotating. If you can recall, in the case of the DC generator, the armature is rotating, the field is stationary. Once again, the basic principle of generating the voltages remains same according to Faraday's laws of electromagnetic induction. That is, here in this case, there is a armature conductors are stationary and it is cut by a rotating magnetic field. Therefore, what we are getting here is static induced voltage in the armature conductors, because the conductors are stationary, the field is rotating. Therefore, the basic parts of the synchronous consist of the stator, in which we are placing the armature conductor, in which there is a generated voltage, and there is a rotor which object is to produce the magnetic field. This rotor is coupled to any turbine, either hydraulic turbine, steam turbine, or the nuclear turbine, all those things. The source of energy what we are getting in the form of the mechanical, that should be coupled to the rotor. If the rotor start rotating, means the magnetic field is cutting the armature conductors, thereby there is induced voltage in the armature conductors. Therefore, the rotor is the field system, that is field system. It is consist of a DC excited winding and the poles, and in the stator we have got a three-phase winding in which the AC EMF is generated, that what we are calling is the armature. The stationary part is the armature and the rotating part is the field system. The principle of operation is same, that is the rotor of the generator, that is the field system is driven by prime mover in the form of mechanical energy you are getting for a different sources. Then a DC current is flowing in the rotor winding, that is field winding, which produces a rotating magnetic field within the machine. Then the rotating magnetic field induces three-phase voltage in the stator winding of the generator. That is, whatever you are getting the electricity is a three-phase supply. Therefore, it is owned for three windings, that is R by B phases, or phase 1, phase 2 and phase 3. Therefore, the generated voltage in the three-phase alternator is a three-phase voltage is inducing in the armature conductors. Then what do you mean by the armature winding? We know that armature conductors, if the conductors are connected, then it is become a two conductors we are connecting back to back, so that it is forming a turn, that is one turn. One turn consists of the two conductors. If the number of turns are connected in series, it become a coil. If the coils are connected, more than two coils are connected in series, then it is become a winding. That is, winding is defined by the conductor. That is, first the conductors are connected in systematic manner in the form of a turn, and turns are connected in series, it become a coil, and coils are connected in series and it become a winding. Then some of the terminologies will see pertaining to the armature winding. Here I have got a one conductor, that is AB, there is another conductor CD, these are connected, this one conductor, this another conductor, then it is a what we are calling is end connection between the two conductors. Now it is become a coil, it is become a turn, it is become a turn, okay, turn or a coil with a single turn, that is it is a single turn or it is a coil with single turn, okay. If more number of the turns are connected in series, it is become a coil. If the coils are connected in series, it is become a winding, okay. This is how we are defining the turn. Turn consists of two conductors. With reference to the figure, that is same thing I explained here, that is AB and CD are the two conductors and their ends are connected, forming an armature winding. The coil may be a single turn or a multi-turn coil. A single turn coil have two conductors, but a multi-turn coil may have many conductors per coil side. That is quite evident. That is, if you are taking a single turn, then it has got two conductors. Then coil means it is more than one turn or a single turn. Then if there is more than one turn, then the number of conductors involved are more. If the more number of the coils are connected in series, then it is become a winding. Then when we are discussing about the DC generator, I told you there are two types of the degrees you are measuring in terms of it comes to the electrical engineering. That is, one is the conventional mechanical degree, the another one is the electrical degree. I defined the electrical degree in such a way that is an angle between two adjacent poles is 180 degree. That is, the angle between two adjacent poles is 180 degree. Therefore, I have got two poles here, N and S. That is, the angle between these two is 180 degree electrical. That is how we are defining the electrical engineering. Electrical degree. For example, if you are taking a 4-pole machine, then the total angle subtended, the mechanical total angle subtended for one machine, that is one circle, that is 360 degree mechanical. However, the electrical degree if you are measuring, because here it is inward 4 poles. Therefore, the angle between first N pole to first S pole, it is 180 degree. Then S1 to N2, it is another 180 degree. Then from the N2 to S1, there is another 80 degree. Then S2 to N1, there is 180 degree. That is, total electrical degree subtended in a 4-pole machine is 360 electrical. Sorry, 720 electrical. However, the mechanical angle subtended for 4-pole machine, either 4-pole machine, 6-pole machine, or 8-pole machine, or 12-pole machine, any pole machine, the total mechanical angle subtended is 360 degree electrical, but however the electrical degree is differs based on the number of poles. That is, now the angle between N and S pole is defining as 180 degree electrical. Suppose I am keeping one coil side or a conductor under the center of the N pole, then the another coil side I am placing exactly under the S pole, then the angle between these two is 180 degree now. Then the span between the two coil sides is called as coil span. That is the space or the span between the two coil side is called as a coil span. It is called as coil span. That is, if you are connecting here, what I did here, there is one coil side is exactly under N pole, the another coil side is under the exactly S pole. Then it is a coil span. Coil span here is 180 degree, 180 degree electrical. If they are connected, then it is called as a coil, and it is called as full pitch winding. It is called as full pitch winding. That is, the full pitch winding is defined in a such a way that the coil span in the case of the coil is 180 degree, means that is one set of coil side is placed exactly under N pole, another set of coil side is placed under the S pole. If the coil span is 180 degree, then such type of winding they are calling as full pitch winding. Then I will take the another example here. Once again, the angle between N and S is 180 degree electrical. That is how we are defining the electrical degree. Then one coil side is placed under the exactly N pole. The another coil side is placed less than 180 degree, or it is shortened by some angle alpha here. It is shortened by an angle alpha. Means the coil span is now not 180 degree. It is less than 180 degree. Then it is called as short pitch winding. The difference between a full pitch winding and a short pitch winding, that in the case of a full pitch winding, the coil span is 180 degree. That is, the angle between the two coil sides is 180 degree. But in the case of a short pitch winding, the coil span is less than 180 degree. Therefore, it is called as, it is shortened by an angle of alpha. Therefore, here coil span is not 180 degree, it is 180 minus alpha. Whereas in this case, you can see here the coil span is 180. Therefore, this winding is known as short pitch winding. It is called as a short pitch winding. Then some of the terminologies relating to full pitch winding and short pitch winding that I am putting in the form of the sum of the points here. That is, coils are arranged according to number of slots per pole per phase. That I will give a clear picture by drawing the for one particular machine. The two coils of the coils are placed in the slots with a span of 180 degree. The span between the two adjacent opposite poles is known as pole pitch. That is, this is also called as pole pitch. That is how we are defining. The pole pitch is nothing but it is the distance between N and S of the adjacent poles. This is also called as pole pitch. It is the span is 180 degree. What is a pole pitch? Pole pitch is the distance between N and S of the adjacent poles, that is equal to 180 degree. Therefore, the winding consisting coils having the span which is equal to the pole pitch over 180 degree electrical degree is known as full pitch winding. Otherwise, the simple way is putting the full pitch winding is, if the coil span is 180 degree or it is equal to the pole pitch, then it is called as a full pitch winding. If the winding coil span is less than 180 degree, or if the coil span is less than the pole pitch, then it is called as short pitch winding. Okay, the same thing I am putting here once again. That is, the coil span is 180 degree. That is, this angle between these two is 180 because the pole pitch is also 180 degree. The coil span is also 180 degree. Therefore, it is full pitch winding. Then I have got a short pitch winding. That is, the coil span is 180 minus alpha, and the pole pitch is 180. Pole pitch is 180. Coil span is less than 180. Therefore, it is called as short pitch winding. Then the coil span is represented by tau p. Tau, a subscript P. Okay. Here also, tau P is the pole pitch. It is a tau P is the pole pitch. What is a pole pitch? Pole pitch is nothing but it is the angle between or the slots between L to S pole. Here the pole pitch is 108 degree, that is represented by T, and coil span is represented by tau C. Here in this case tau P and tau C both are equal, therefore it is called as pole pitch. Here the pole pitch is equal to the coil span, that is equal to 180 degree electrical, then it is called as full pitch winding. Whereas in this case you can see here this is the pole pitch, that is 180 degrees of pole pitch, whereas the coil span is less than 180, that is 180 minus alpha, then this is called as tau C, therefore it is a short pitch winding. If the tau C is less than tau P, then it is called as short pitch. If the tau P and tau C they are both are equal, then it is called as the full pitch winding. These are some of the terminologies relating to the full pitch winding and the short pitch winding. Here the S is the total number of slots, that is the total number of slots it is for the armature winding to place. S is the total number of the slots. P is the total number of poles. P is the total number of poles. Then this number of poles, this number of slots should be distributed to P number of poles. S number of slots should be distributed for P number of poles. Then how to distribute that? It is what we are calling is number of slots per pole. That is, we know the number of slots, we know the number of poles, therefore number of slots per pole is S by P, that is represented by N. Therefore the number of slots per pole, that is how we are defining is N is the number of slots per pole, it is S divided by the P. Then there are conductors are distributed between the for each pole, that is each pole. Then here you have got a three-phase system. You have got a three-phase system. That is the number of slots which is allotted between the two poles, once again bifurcated for three different windings. That is a phase number 1, phase number 2 and phase number 3. That is, first what you have to do is you have to distribute the number of slots per pole. Then whatever the number of slots per pole, once again redistributing for three different phases, that is phase R, Y and B, or phase 1, 2 and 3. Therefore I am calling here the number of slots per pole is already S by P. Then once again they are redistributing for per phase. Therefore if it is here 3 phase, therefore divided by 3 out of 8. How we are getting M? N is the number of slots per pole. Then what we need is number of slots per pole per phase. Therefore how to get M? M is equal to N divided by number of phases. In this case it is 3. Therefore in general that is S by P into number of phases, so that what I am getting is M. M is the number of slots per pole per phase. Then the beta is the angle between the adjacent poles. Adjacent slots, that is the angle between adjacent slots. For example, if there are 6 number of slots is there for between N to S, or the number of slots per pole is 6. Therefore, what is the angle between the adjacent slots? That is, for between the two poles it is 180 degree. 180 divided by 6. 6 3 is a 180. 30. That is what you are getting is the angle between the adjacent slots. Here you are getting is the 30 degree. It is the number of slots per pole. This is how we have to find out. I will take an example and I will clarify this. That is the angle between the two successive slots can be calculated as 180 by N electrical. Then the tau P is, I told you, pole pitch. Tau C is called as a coil pitch. If the tau P and tau C's are equal, then it is called as a full pitch winding. If alpha is a short pitch winding, in that case the